So yeah.
Yeah, all good. Thanks, Ian. Got it.
Perfect. Thank you. Yeah, my name's Ian D. I'm Associate Director at Bluesky in charge of R&D and innovation. Stepping in at the last minute, I apologise. I do have a bit of a cold. I'm a bit croaky, but I'm sure we'll manage to get through. But as we were saying, this is an overview of the National Tree Map. And what I wanted to talk through is not just what the tree map is, but why it's an important data set, how we make it, a couple of the applications to maybe stir up some ideas in those attending, and then look at actually what we do with the National Tree Map. It's obviously the way that we update it, the way that we evolve it, all really important things in product life cycle as well. So to start with, just a little bit about Bluesky. We were formed in 2002, and we have become the UK's leading commercial airborne remote sensing company. So we have a fleet of aircraft, sensors, operators flying up and down Great Britain and Ireland, capturing largely nadir imagery, but LiDAR, obliques as well. And in 2025, start of the year, May, we were acquired by the Woolpert Group, who are a really interesting organisation, a big American geospatial company, turnover about $800 million a year. So although obviously our conversation earlier was, are we Bluesky, Bluesky World, Bluesky International? We are sort of officially Bluesky International, part of the Woolpert Group, which makes our LinkedIn handle extremely long. But I would imagine over the next kind of 18 to 24 months, we'll simply become Woolpert UK or Woolpert Bluesky or something along those lines. But importantly, we are the sole provider of national aerial imagery and height data to the GB government. That is now on an unprecedented 2-year update cycle. It was previously 3 years. We also cover the Republic of Ireland too, which is on a 3-year update cycle. Got about 200 people in the business, excluding the Woolpert stuff, with offices in UK, Ireland, India, and US. With Woolpert, there's about 3,000 of us, but we don't count ourselves quite part of that yet. And we've got clients across every sector, really. We work insurance, climate, architecture, engineering, and construction. Anything and everything where there's a need for geospatial data, we are part of that. In terms of the National Tree Map, what it is a map of trees. When I say trees, that's how we've classified vegetation above 3 meters in the data. So we have effectively Great Britain and Ireland's most comprehensive map of vegetation over 3 meters. Now, it doesn't include all trees. We can sort of have a look at that in a little bit of detail shortly. But effectively, we created this data from aerial imagery and photogrammetric height data. So if you're familiar with some of the data sets that we produce, or with photogrammetric data, ortho-rectified aerial photography, and the DTM and the DSM that are created as byproducts of that. In terms of that segmentation, capturing individual trees, as I say, we don't capture every tree because we segment trees at the canopy roof level. So if you think of what you can see on an image, what you might see on a drape, a 3D drape, that's how we segment the trees. Obviously, if you had LiDAR, you could see below the canopy and do a more detailed segmentation, but the currency and quality of LiDAR is not necessarily that prominent across Ireland, certainly, parts of Great Britain as well. In terms of the data that we provide, we do create centroid points, which you can think of as the top of the tree, the seed of the tree, the canopy polygons, which give you an accurate outline of the extent of the canopy, and then, as you can see in the image on screen at the moment, what we call an idealized crown. So just taking the area of the canopy and turning it into a circle. And every single tree that we've captured includes min, mean, max height, canopy area and perimeter. And we're now moving NTM to a 2-year update cycle to match the aerial imagery coverage plans. But why do we need NTM? It's a sort of question I get asked. There are lots of open data sets out there now, which are all really useful and all have a place, certainly. But those alternative data sets don't often map individual trees, often only broad classifications. Here's an area of woodland, for instance. So the tree map really takes that detail to the next level. What we found is inventories at local authority level are often incomplete. There are some local authorities who do great jobs in capturing tree data, but largely the records aren't great, and therefore, the open data sets and the governmental data sets don't necessarily have the currency, the coverage, or the quality that you need for some of the ecological or environmental use cases where you do need individual tree level intelligence. Also, whilst there are open source input data, the Environment Agency LiDAR you could use to produce your own tree map, actually taking that vast data set and processing it and scaling that up to national level are barriers for a lot of companies. Bluesky, we've got the infrastructure, we've done it before. So, we see our job as sort of undertaking that work and taking on the mantle to produce this data. Also with NTM, every 3 years previously, now every 2 years, you've got a consistent national baseline. And of course, universities, researchers, public bodies, and commercial organisations all need trusted high resolution data. So NTM really does kind of fill that gap and bring that information to the users that need it. In terms of how we create it, there's some quite interesting techniques and technologies in there. Effectively, we bring in 4-band aerial imagery. So we've got RGB, but we've also got an infrared band and that photometric height data. The RGBI imagery allows us to remove non-veg features. So if you think of water, roads, buildings, cars, whatever might be the imagery, and then we've just got the vegetation left. From there, we use the DTM and the DSM to create a canopy height model, effectively subtracting the DTM from the DSM to get that canopy. And then we can remove anything below that 3 meter threshold. And I will come into what happens below 3 meters a little bit later in the presentation. From the canopy height model, we can then identify the seed points or the tree tops, and then we use a watershed segmentation method, which if you think, if you were pouring water onto the top of the tree, it flows downwards. Where does it reach its natural endpoint or start to see a barrier and would have to go uphill again? And that's how we delineate the tree canopy. And the attributes previously extracted, plus we calculate that circular idealized crown. Any information on the processing, I'm happy to share in a bit more detail later. In terms of use cases, there's quite a few, but I chose this one because it's definitely come into prominence over the last maybe 12 to 18 months. You might be aware now that there are new Biodiversity Net Gain legislations in place. I don't know if that's the same in Scotland or Wales, but certainly in England, where you now need to leave a site that you're developing better off once the development has happened than the state it was in pre-development. And that can include working on that site, or you can invest in increasing biodiversity in adjacent sites. So again, if you think you need to effectively understand what's on that site, the National Tree Map becomes a perfect data set for that, assessing tree presence, tree shape, and tree size pre any development, so housing estate, industrial estate, whatever that might be. The NTM also supports calculation of tree attributes relative to habitat distinctiveness. As we say, certain tree sizes, certain tree shapes, they do differ across the country. If you start to overlay that data with potentially information on whether it's coniferous deciduous, adding even more information into that. Then importantly, we get this element of the 2-year update cycle actually enables us to monitor the site and audit the developer to see if they are undertaking the biodiversity net gain work that they promised they would undertake when they were awarded the planning permission. So that gives us a really powerful way of ensuring that the developer is doing exactly what they said they would do and holding them to account for their actions. Also, I said you can increase biodiversity in a site adjacent to your development, doesn't need to be on it. And as it's a national data set, we can actually have a look at any site across Great Britain or Ireland and see what's happening there over time. So again, really powerful use of NTM. Also, this isn't a data set that's been derived by hand, by human interaction. It is an objective, empirically observed data set. So it does provide a repeatable evidence base for BNG compliance without being subjective, which is absolutely critical in these instances. Use case 2, urban planning. I have cheated a little bit here and put a few use cases in, but I think urban planning, along with biodiversity net gain, are probably one of the hot topics at the moment when it comes to trees. And really, with the National Tree Map, what you've got is the best-in-class tree data set for urban environments. When you're looking for individual trees or small clusters of trees, there isn't a data set that really competes with National Tree Map in that regard, especially those sort of standalone trees that are missing from those other data sets. Now, in terms of the applications, if you think of some of the planning toolkits that are used at local authority level, quite a new one is the 330-300 concept. So you should be able to see 3 trees from your house, have 30% canopy coverage in your neighbourhood, and live within 300 metres of a green space. So in terms of ensuring people have access to green space for their physical and mental well-being, National Tree Map can play a really important part in that process. Also, areas where there are tree or canopy deficits, where shade and climate is potentially an issue, or where green space and tree canopy is limited. Obviously, we want equitable access to these trees, these green spaces, and the National Tree Map can be part of that process as well. And of course, if you are looking at scaling up your tree planting, whether that's for better air quality, whether that's for health and well-being, whether that's purely for aesthetic reasons, the National Tree Map can help you understand where you should prioritise and where your activities can have the highest impact. And again, the national data set, the national baseline, and that 2-year update cycle really does provide that repeatable baseline for monitoring of gain or loss, and of course tree resilience in terms of developments that are happening within the city. We are aware that NTM has been NTM for some time now. I think we started creating it in around 2011, and it hasn't fundamentally changed as a product in that time. It's always been canopy delineation plus height, area, and perimeter statistics. So one of the key things we're looking at the moment is how do we take NTM a little bit further? And this includes the development of what we're calling the NTM Plus and the NTM risk layers. NTM Plus is the corralling and collating of lots of existing open data to provide additional locational context for each tree, whereas NTM risk is taking it to another level and saying, what is the tree risk to the nearby assets, whether that's buildings, road or rail. Now, this is going to provide around 70 additional new attributes to NTM across NTM Plus and NTM risk. With NTM Plus, some examples here, we have in or out of conservation areas, so national parks, SSSIs, SACs, AOMBs, although they're not called AOMBs anymore, I believe, designated landscapes maybe. The nearest UPRN, so if the tree is within a cadastral boundary, we tell you which property is associated with that cadastral boundary, and also the administrative responsibility. Previously, we just said which OS1K tile the tree was in. Now we say what district, what county, what postcode. So who's got the administrative responsibility for that tree? In terms of NTM risk, again, taking it another step further and saying, okay, well, how does this tree or does this tree pose a risk to my assets? So we now have information, which you can see on screen here, on how many buildings are within tree fall distance. So the redder the tree in the image, the more buildings are near it that could be impacted if that tree was to fall. And we're also looking at the proximity to roads, rail and water and how it would affect people's travel to and from work. And also in terms of insurance risk, again, soil type, land use, agricultural grade, thinking of subsidence, heave, and all those kind of things that influence how the tree behaves and the impact it might have on the buildings nearby. We're also currently in the middle of, about 10 months into a 2-year Innovate UK programme with the University of Leicester, which is a knowledge transfer partnership. We have a full-time KTP associate working at Bluesky's office. He's been with us since February. And what we're effectively looking to do is really, I guess it's the holy grail of tree intelligence, is to add tree species attribution to NTM at national scale. So every single tree having some kind of information about the species. It's a big challenge and a big ask. And we have a pathway that we're kind of working down to achieve that. The first is to improve the segmentation. We want to make sure that if we are attributing tree species to it, we're attributing that to the correct tree. So improving the segmentation is critical to that. And then also working on deciduous versus coniferous classification. Of course, once we know whether it's, I should say, evergreen or deciduous, really, to be accurate. But if we know whether it's evergreen or deciduous, then we can start to tell the species from a smaller pool of potential options there. And we're about 80% accuracy to date on that. We've got test areas in Nottinghamshire, across Wollerton Park, which is a sort of urban parkland, Kielder Forest in Northumberland, which is man-made plantation, largely coniferous, Thetford Forest in Norfolk and Suffolk, which is a plantation but mixture of deciduous and coniferous, and a large area of Lincolnshire, which is agricultural. So we're building our kind of label data set and training based on there. We're also starting to bring in LiDAR where available, our own LiDAR at the moment, because we can audit and account for the quality of the currency of that LiDAR, whereas we can't with some of the open data. And that's also going to help us build up that species data and bring that in. The idea here will be that, at the end of the 2-year, if we don't have the species data already attributed, we'll certainly have coniferous, deciduous, potentially some key species or maybe even genus level, and then a pathway to having full species data over the preceding sort of 2 to 4 years, I would think. But we're being ambitious, and 2 years is what we're aiming for. I talked about vegetation under 3 metres, and that is where our national Hedgerow Map comes in, which is a sister product to the National Tree Map and is created simultaneously. We don't have national coverage of this at the moment, but we do have lots of areas created now. And as we refresh National Tree Map, that will complete the national coverage of the Hedgerow Map as well. Similar techniques and input data sets utilised, but rather than vegetation over 3 metres, we look at vegetation between 0.5 metres and I put 0.2, I mean 2.9 metres in height. Additionally, with this data, we do include hedgerow volume and we do put centre lines in. And we are finding a lot of people are using this data now for habitat mapping, biodiversity, biomass, also looking at where potentially solar farms could be placed and trying to delineate land ownership and land usage in agricultural areas for renewable energy. And we've just started to partner with the University of Aberdeen on a PhD looking to add species and genus level information to hedgerows as well. I believe the interviews have been completed for the candidate and they'll be in post from the start of next year, which is exciting for us. So that's a little overview of what the tree map is, why it's important, how we create it, and what's going to be happening over the next few months and years with the tree map. If anyone has their camera to hand, they can blip my QR code and that will link them with me on LinkedIn. But really, that's everything for now. So happy to field any questions. I'll just leave this slide up for another sort of 15-20 seconds if people want to grab it, and then I'll switch off and I'll pop my camera back on.
Now, I'm assuming you can see our Digimap homepage. I'm sure I'll see something in the chat that says not if you can't. So once you log into Digimap, you need to go to the Audience Survey collection here. go into the OS Digimap application here, and you will find the National Tree Map is available in two ways. Once you zoom in on a particular area, you can then add it as an overlay in the left-hand panel. So you'll see that the National Tree Map points, crowns, and canopies are greyed out here because I've not yet zoomed in enough. When you see the data, you'll see exactly how busy it is and why you can't view it too far, zoomed out too far. So if you zoom out too far, you start to get just a big green blur. But as you zoom in, of course, you can start to see the individual points. You can then add the tree map crowns and the canopies on top of those, and you can switch them over to see what it is you want to look at most closely. You can zoom right in to the master map data, so it'll give you individual trees like this, and you can see the individual points. Those are the points and their crowns. And of course, as you zoom out, it starts to get a little bit blurry, even though the trees are mapped at individual street levels. You can fade the background out a little bit using the slider at the top, which allows you to see things a little bit more easily. That depends on what scale you're looking at and how colourful the background map is. Sometimes that's more or less useful. You do get a real sense, even at this scale, of exactly how many trees there are in this country. It's quite green, which is pretty good. So if you want to then download the data, you need to go to the data download tab on the left-hand side here. It's the bottom one of all the tabs. Let me just show you there. So overlays is the one if you want to see it on the screen already, and the data download tab is the one if you want to download it. So if you have a subscription to this and you have already agreed to the license agreement, you should find the National Tree Map listed in this section here. You can then zoom right out, and the pink area there with this little yellow grid highlighted will show you the area that it covers. As you can see, Northern Ireland isn't covered and the Isle of Man isn't covered, but we've talked about that. We'll see if we can address that at some point. To select the area you want, zoom in, and you should find, and just turn that pink layer off. Find the area you want. You can use any one of these tools at the top here to select the area you're interested in, like so. Check the National Tree Map, add it to your basket. You then get a choice of 3 different formats: geopackage, geodatabase, or that somehow doesn't seem right to me. Okay, I'll have to go and check that. And you can pick particular layers if you wish to have just one or all. Let me give my download a name, and I can request the download that way. What I will get then is an email sent to my registered email address that will give me a link from which to download the data. And it's as simple as that. So if you think you do have a subscription, but you can't see the National Tree Map listed in this left-hand panel, go back to the Digimap homepage here and check the license agreements link in the top. It is entirely possible that if your university has taken a subscription part way through an academic year, you haven't managed to agree to the license agreement at the point at which you registered for Digimap. If all these links are green, it says license accepted, you're all good to go. If it's white, like this one, no, I don't have any white ones. That's not a surprise either. You can click on the arrow to open it, and you can accept the licenses that way. Then you should find that the National Tree Map appears in your list on the download data section here. That's a quick tip. If your institution doesn't yet have a subscription and you would like one, or you have need of it, the best thing to do would be to contact your learning resources people, your library, your computing services, the people who look after databases and acquisitions and collections and so on. We can help point you at the right person who's purchased other Digimap licenses, and then you can make your case for that locally. Unfortunately, we can't grant access to the National Tree Map on an individual basis. There are practical reasons for that as well as licensing reasons, but that's the way to go about it. Can you show how to access the license information again? Okay, so Stephen, I'll start again. If you cannot see the National Tree Map listed in here in the OS collection under the data download tab, just to recap, there's the data download tab, and it should be listed in here under a National Tree Map section. If you can't see it there, go back to the start page where you can see all the collections, and there should be a license agreements link at the top there. If you can't see a license agreements link, chances are you have already agreed to all the licenses that are available to you. If you've got a link there that says once, and mine is odd because I'm logged in as an Adena person, so we do all sorts of funny things for testing purposes. If you see there's a 1 or 2 or 3 or whatever here, click on the license agreements link and you'll find a list of all the licenses available to you within your institution. If they are white, you need to click on them and agree to them, and that will make things available to you when you go back into the service. If they're all green, then you've already agreed to everything that's already there.